So if we're asked to solve this graphically and algebraically, let's talk about graphically first. So obviously this involves rational expressions. We have an equation, we're trying to solve for x. So graphically, there's actually two really different ways you could solve this graphically. The first way would be to represent the left side of the equation and right side as separate functions. Okay, so we want to find the corresponding function. This is just in terms of x. So it would be like y equals 1 plus 2 over x, right? And y equals x over x plus 3. So that's what graphically 1 is. And then, of course, we find intersection point or points. And then use the x values as our answers, as our solutions. Okay? So that's the graphically 1. Graphically 2, okay, would be to so we want to move all of the terms to one side of the equation and let it equal 0. So if we move terms to one side of the equation, and other side would be then equal 0, then do you remember what we do here to solve for x graphically? If we do that, what are we looking for? Well, first of all, we're going to graph that function, graph the single function that we've now created, right? And what are we looking for? Very good. X-intercepts. So the x-intercept or intercepts are your solutions. So that's the two different graphing methods, which we'll do right now. So you might want to grab a graphic calculator if you don't have one with you right now. And I'll show you exactly how to do that on your graphing calculator in a second. So grab a graphic calculator if you don't have one. So if you have your graphing technology, you can use Desmos if you want. Online there, you can use a graphing calculator simulator like we have right here, or your graphing calculators that you have in your hands there. So what you want to do again for graphing, the step number 1 or the method number 1 is to graph each of them separately. So I'm going to do that. So 1 plus, make sure you use your brackets. Okay, 1 plus 2 divided by x, and the other one would be x divided by bracket x plus 3. Okay. Now, as far as your zoom goes, I'd just recommend just a standard window or whatever. We'll see what happens. So there is the first one, and there's the second one. Okay. So what we're trying to do, and if you have a newer calculator, you might have these graphs in different colors, which might be kind of nice. A little tough to see right now. But we want to find the intersection point or points. So we probably could zoom in just a little bit. Let's just see if we can zoom in. Number 2. And I'll move that center of the screen about there. Hit enter. So here's the first graph coming. And here's, oh, look at that. Right there we have at least one. Okay, we have one intersection point right there between the two graphs. So to calculate the intersection point, we want to go second function, calculate, and then hit our number 5. We'll calculate the intersection point. And it'll show up on the left screen, your first function, you hit yes. It should flip to the second one, you hit yes. And then the cursor, it's kind of tough to see, it's behind the numbers, but I think, where is it? Did I get a 1? Yeah, so the cursor is right there. You want to put that cursor close to wherever that intersection point is. So then the calculator will calculate the intersection point, and of course it's going to be decimals, right? It's going to be decimals, but we're interested in the x values. Okay, so negative 1.2, that appears to be one solution. So x equals negative 1.2. As a fraction, that would be what? Negative 12 over 10 or 6 over 5. Okay, so Usually in preparation for calculus, we're going to want to try and use fractions when we can, but if you're using your calculator, I'm fine with decimals. So is there another solution? Well, we may have to zoom back out here. And so let's look carefully. So there's going to be our first one coming right there. And is there another one anywhere? Okay, is there another one anywhere? So they cross here. They appear to be approaching an asymptote here. That they don't appear to be intersecting over here. So there's one there. Do you guys see another possible one, or can we explore this any further? You could change your window settings and zoom out and see if there's anything else over there. Well, I tell you what. Let's just explore the second method, because we are looking for x-intercepts here, and this is kind of tricky with the asymptotes and all the different crossovers and stuff. So let's take a look at how we would do the second method and then see if there's another solution or not. So in the second method here, what we would do, and I'll just kind of maybe erase some of this, go back to our... So what we want to do is we want to get all the terms over to one side. Doesn't matter which side at all. Doesn't matter. So I'm going to, let's see, I'm going to move this one term over to the left. So it's going to be 1 plus 2 over x minus now x over x plus 3. And that's going to equal 0. So if we have an expression equaling 0, if we were to graph that, the corresponding function, then we would be looking for the x-intercept, or intercepts would provide the solution. Because basically, whatever value for x would make this whole side 0 is what we're looking for. So then we want to do this. We want to go y equals this whole thing right here. It's just a combination of all these terms. So let's do that. I think we're going to have to erase everything that we've done here so far. So let's just do this one big one here. So 1 plus 2 over x minus x divided by I'm using a copious amount of brackets here. Hopefully that's gonna work here. Alright, so let's graph that and see what happens here. So it appears, guys, look at this. We have one intercept right here, and it appears that there may be a horizontal asymptote that looks like it's around 0. Okay? So let's first of all find this one. So second function trace, and we want to find this, which one? We want to find these 0? Okay, so the left boundary now, we have to go to the left of where we think this intercept is. Hit enter, go over to the right, hit enter, and enter again. We should have negative 1.2. Okay? Very good. So you can now, if you want, we could look to the left. So negative, let's go negative 50 for x and positive 50. And we could look all along this x-axis to see if there's any intersection points. Going to be a little tough to tell here, isn't it? Because we're zoomed in quite a bit. So let's change our y values as well. Let's make our y, instead of going negative 10, let's just go, negative even 0.5, because we're looking to see if it touches the x-axis, right? So even from negative 50 to positive 50 here, it doesn't appear to be touching. So it looks like we just have the one intercept there. Okay? All right? So one solution, x equals negative 6 over 5, or 1.2.
Wait. What about x equals negative 3? These are 6 squared because it's restricted.
What about, sorry, x what?
X equals negative 3. It's the asymptote, which means it's restricted. Yeah.
Right, but the x equals negative. Okay, so x equals 0 is restricted value. Yeah, okay, so let's finish that off. I mean, so x cannot equal 0 and cannot equal negative 3. Okay, so if these were one of our solutions, we would have to reject them. The only solution we have is negative 1.2, so that's not one of our restricted values. So yeah, we want to make sure that our answers are not restricted values. So yes, you could identify the restricted values first. That's great. I guess for me, I knew these weren't this wasn't a restricted value, so I wasn't focused on that. But yeah, good point. Make sure that we don't state a restricted value as a solution. Okay, good. Any other thoughts, comments? Okay, so that is graphic. Okay, so in this original question, we did want to solve both graphically and algebraically. So let's get some practice with that as well. So you want to write your equation out here, and then if we follow our steps from previously in this lesson, we can note restrictions at any point before we do any simplification. So we know that x cannot equal 0 and negative 3, as we've noted. So we'll just keep that in mind. Be a good idea to get rid of our denominators, right? So let's do this. Let's multiply every single term by x and by x plus 3. So that's going to give us x times x plus 3 over here. The x is going to get divided out in the second term, so it's going to be 2 times x plus 3. Everyone see that? This x will divide out with this x. And then when we multiply over here, the x plus 3 will divide out with the x plus 3, so that's going to equal x squared. So is everyone okay with that? Does that look right so far? Okay, it's a way you can get rid of our denominators. So let's do some expanding, some gathering like terms, and see what happens. So x squared, and then plus 3x, okay, when you expand this out, plus 2x plus 6 equals x squared. All right. So now the solving process, we want to gather all the like terms. So I see an x squared on both sides. You know what? If you see the exact same term on both sides with the same sign and everything, then they cancel each other out. Because really, if we subtract x squared from both sides, look at what happens. Those are both gone on both sides. So x squareds are no more. Now, is that a problem?
No.
It's not, because we still have an x here. So this is going to make this actually pretty easy. This is going to be 5x equals negative 6 when I pop this over to the other side and gather these up together. So that's going to be x equals what? Negative 6 over 5. And that is our answer here. So it's not a restricted value. We double check with what we have up here, so we can be confident in saying this is our answer. And of course, you could check algebraically by putting this in. You should get both sides being the same. Okay? Any questions on that? No. Pretty easy? Easy peasy? Yes, question. Okay, so the question was about the graph. What's this with this vertical line? It looks like there's an intercept here and possibly an intercept here. But that's how this calculator shows the asymptotes. So you see the asymptote is at negative 1, 2, 3.
Yeah.
And the asymptote at 0 technically, or 2. So that shows you where your restrictions are. So yeah, I mean, good point. From the graph, any vertical asymptotes or gaps, you're not going to be able to see the gaps very well. But any vertical asymptotes that show up here are going to be your restricted values. Okay? All right. Awesome.